QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's have 3x squared plus 10x minus 9 equals 0. Is this trinomial factorable? Yes or no? The answer is no. Next question. What should be the constant to be added on both sides for the completing the square process? And it should be 25/9. Now, what are the roots of the given quadratic equation? And the roots are positive or negative 2 square root of 13 minus 5 all over 3. Did you get 3/3? If not, please continue viewing this video. Notice that for this given quadratic equation, our a coefficient is no longer 1 nor 2. In our previous videos, we were able to also manipulate equations where the a coefficient is 2, but here it's 3. Again, the a coefficient here is 3. The b coefficient is 10. That's positive 10. And your constant is negative 9. If ever this is not factorable, we can use completing the square method, and we might divide all terms later by 3. But of course, let's check it. In our answer in a while ago, it was non-factorable, but let's check it here. So this is factorable if we have AC, so 3 times negative 9, which results to negative 27. If we could locate a pair of factors to get negative 27, and when added, will result to 10, this is factorable. If it's not, as mentioned, we will proceed to the completing the square method. We do have as well quadratic formula, but here we will not be using it. We will be strictly focusing on this method, or the method that is needed for this equation, so that we can also try to master important steps. So negative 27 can be a product of 1 and negative 27, as well as 3 and negative 9 as given here. Or the other way around, negative 1, positive 27, negative 3, and positive 9. But when you add any of these, they will not result, or the results for each pair will not result to 10. This means, as mentioned, we are going to use here completing the square method. In using the completing the square method, we will be using or we are going to look for a certain value of the constant. No longer negative 9 is in our given, because that value of negative 9 do not make a perfect square trinomial, quadratic trinomial, which could be factored later. So we will be looking for the appropriate value of our constant. Of course, our given is 3x squared plus 10x minus 9 equal to 0. Let's move out 9 in this area here. So you will have 3x squared plus 10x, that's 10x, and it's equal to 9 here. We will be looking for an appropriate c in order for us to really come up with a perfect square trinomial. So first, let's divide. As mentioned, we will be dividing 3 on all parts, no longer 2 but 3, so that your a coefficient here for your new version of the formula will be 1. So you'll have x squared plus 10 thirds x is equal to positive 9/3, right? So here comes the process of solving the appropriate C. I'm labeling it C sub 1 so that we will not be confused with the original C. This is actually B over 2 times the square root of A. And then you square it. Some formulas do not use square root of A, as here we already have 1. But I'm just placing it there for better analysis. At the same time, the B and A coefficients here are not this A and B, but for new. So you could also use here B sub 1 and A sub 1. Nevertheless, this is what will happen here. Can you expect fractions here? Because your B is 10 over 3 all over 2 times square root of 1, and you square that. Okay? So look at the first expression. We have fractions, and a fraction rather to be divided by an integer. So you could use here the reciprocal of your denominator and make it multiplication. So 1 over 2. Of course, square root of 1 is just 1, and then you square it. 10 can be divided by 2, so you will have 5. So the square of 5 is 25 over 9. And it's the appropriate value of our C coefficient, or the constant. So instead of this, we will have x squared plus 10 thirds x plus 25/9, and we are 100% sure that this is a perfect square trinomial. But don't forget to do the same thing on the other side. 9 over 3, and then plus 25/9. Okay? Now, of course, you will be adding that, and we could also factor this now, because that's a perfect square trinomial. You have x, square root of the first term, square root of the third term, 5/3, sine of the middle term, plus, and this is your square of a binomial taken from your perfect square trinomial. You may want also to review this set of process. And it's equal to, okay, if you're going to have LCD, that's 9. Okay, so you have 9. 9 divided by 3 is 3. Okay, sorry. 9 divided by 3 is 3 times 9. You'll have 27 plus 25. You'll have 52. Again, 9 divided by 3 is 3 times 9, 27. 9 divided by 9 is 1 times 25, 25. 27 plus 25, that's 52. Then we take the root of both sides. Don't forget that when you take the root of a number, that's plus minus here. So you have x. Let me separate here so that we'll have enough spaces for the rest of the processes. You have 5/3 is equal to, again, plus, minus, and let's try to separate the numerator from the denominator, because both of them can still be simplified. I mentioned, again, both of them, aside from 9, can be simplified to 3. 52 is also a product of 4 times 13. For those who are wondering why we will have 4 times 13, this again, the reason why I'm a firm believer that before quadratic equation, we need to understand how radical expressions work. So we need to review radical expressions before we go to quadratic equation, because getting roots like this, you will be handling rather radical expressions, and even in your, what do you call this one, quadratic formula. So this is, let me just copy 5/3. So you will have plus, minus. Now again, I'm just going to write it here. Square root of 52 is, or can be written as square root of 4 times 13. And the product rule, or the multiplication law for radical expression, since 4 is a perfect square, you can move that out, and you will have the square root of 4 is 2, and 13 will stay as your radical. Again, radical expression, this is the concept. So you have plus minus 2 square root of 13 all over square root of 9, which is easy, 3. So we subtract then both sides by 5/3. Here your roots are plus minus 2 square root of 13 over 3 and minus 5/3. And since these two fractions have the same denominator, you have this first root of yours, the positive 2 square root of 3 minus 5, that's minus 5, all over 3. And for your second root is the negative version of 2, sorry, that's 2, forgot to place 2, square root of 3, still minus 5, all over 3. So as you can see, you are expecting radical expressions because for one, you are using completing the square method because it's non-factorable. And second, you are using concepts on radical expressions to which you really need before quadratic equations like this. So these are the roots of the given quadratic equation using this process for this QuadQuiz. Subscribe now!